Okay, folks, we're going to do a quick exercise here called Paint the Rainbow. And there's no reason to hand in this exercise here. It's just to sort of test out to make sure that you understand the concepts and to try some things out with your CPX. So, again, I've just plugged in my CPX here. I haven't launched Moo yet, and I can see I've got CircuitPy right here on the desktop, so everything is working fine. If you happen to plug in and you don't get CircuitPy, instead you get cplay boot, remember what you need to do is just drag over your UF2 file, this Adafruit CircuitPython file here. Just drag that over and your CircuitPython should show up. Every once in a while you might have to double click the reset button for that to show, but you should get CircuitPython up there and running. Now if you put anything from make code on your CPX, that's going to wipe out the CircuitPython file, so you can just drag it over again. So with that said, let's go ahead and open up Moo. And here we are launching. And Moo always takes a little while to load. And so I'm not sure if you've got some code which is up or not. Mine just says I've got untitled code here. And typically what we do is we set up those 2 lines of code that we need. And that's the line to import the CircuitPython libraries for the Circuit Playground, and also to make sure that we can use the time functions too. So you might actually have another tab which is up here. So let me load to see whatever's on my Circuit Playground Express right now. Yours probably looks like this, or something like this, where you've got a code.py file in here, but if not, don't worry. But if you do have a code.py file in there, what I'm going to do is I'm just going to highlight these first 2 lines that we know work, and I'm just going to do a Command-C or Control-C if you're in Windows. And then since I don't need this tab anymore, I'm just going to click on the X to get rid of that code.py file, and then I'm going to paste these 2 lines in here. So this is where I can go ahead and I can start typing in some code. Now, just so that we can remember some of the stuff that we've done before, why don't we hop over to the serial monitor and refresh ourselves there. So if I go ahead and I click on serial here, what this does is it shows me what's running on my Circuit Playground Express. And I've got a bunch of stuff which is showing up here because this is the last example that I did in, I think, the second class that I've got here, and it was showing what's happening with the different accelerometer axes. So what I'm going to do is I'm just going to Control-C to stop things. And if you do a Control-C and you press Enter, you should get this dash 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 in here. Or, I'm sorry, the greater than symbol, which says, hey, now I'm in the serial monitor. And again, what the serial monitor is it just executes things line by line in the CPX. Now, before you can go ahead and type in anything from the CPX library, what you just do, again, just remember, each time that you get in here for the very first time when you get greater than, you can just copy this from Adafruit line here, this one that reads in the library, and you can paste it in down here, press Enter, and now you're good to go. So if you've got your CPX in front of you, you can start to type in some commands, like, oh, how about CPX dot, and let's see, what were some of the ones that we were doing before? We were saying pixels dot fill, and then we can do an open parenthesis and then a second open parenthesis. Remember, what goes in the second set is an RGB, 3 different values from 0 to 255. So if the R is red, if we did 255, and then if we did 0, and then if we did 255, and then close parenthesis, close parenthesis. So again, inside the one set of parentheses, we got another set of parentheses with the 3 values in. The red value of 255 says turn up red all the way. The 0 means there's no green. The 255 for the blue value means turn up blue all the way. And when you press Enter here, if you take a look at your Circuit Playground Express, you're probably seeing something which looks like nice bright pink lights which are showing up. That's great. And if you want to turn these off, you can just do cpx.pixels.fill, open parenthesis, 0, 0, 0, close parenthesis, and that shuts them all off. So great, we understand now how we can go ahead and manipulate some of the things here. Now let me give you a quick exercise, and I'm going to introduce you to just one other additional command in here. So remember when we paused some things previously? We had done in make code, there was a pause command. Well, there's actually a command that we can use in CircuitPython, and it's time.sleep. So time is the library that we're dealing with. Just like when we deal with CPX, we say CPX dot. Well, we use our dot notation here, which says, hey, go into the time library and then use the dot sleep function inside of this. And when we pass a 1 in here, that means 1 second. So you can put in a fraction of a second as well. This 100 millisecond was 1/10 of a second when we did make code in here. So what you've got to do, though, before you can go ahead and use time.sleep is you've got to go ahead and import time. Now, what we're going to do is we're going to actually actually going to write some code. So you want to write a code.py file, and then you want to save that out to your CPX. And I want you to write code that's going to print the following colors, and you wait 1 second in between each color, and then restart from the first color. So by saying we're going to print them and then restart, that means we're going to go through the equivalent of our forever loop. And remember how we did this before? We did this slide in class here. We said the equivalent of a forever loop in CircuitPython was where we say while true. Just updated the circle here on the slide so it looks more like the slide that you've got now. It was a little squirrely on mine for some reason. And so what essentially the while loop does is it says while, and then it evaluates what's after the word while and before the colon. So it says as long as this is true, do everything that's been indented. And well, since true is always true, I know that sounds redundant, but it'll do everything that's indented here over and over and over and over again. So again, what we're going to do is I'm going to ask you to, as you paint the rainbow here, go through and again print each of these colors here. So if this is RGB, the first one has got red turned all the way up and then nothing for green and nothing for blue. Then we've got red and then we got a half green and we got nothing for blue. So you can see we're going to continue to go down here, and you want to pause for 1 second after each of these colors is displayed, so you know that you use your cpx.pixels.fill with the 2 open parentheses and then these numbers and the 2 closed parentheses for each of these, and then you should have your time sleep in here for 1 second after each one of these. So why don't you go ahead, type in those statements in your while loop. I'm going to pause right here, and then you can unpause and we'll do this together. I shouldn't say that we're going to do it together. What I can do is actually show you this running and functioning code. Actually have the answer right here on the next slide, so you can see how we set this up. You know, remember the kinds of things to look for some reason this isn't working on your CPX. Do you have for your CPX pixels.fill parentheses first to say, hey, I'm going to pass in a color, and then another parenthesis because this is that strange thing that we said is called a tuple. It expects parentheses, and then it expects, in this particular case, 3 values. So that's why we've got 2 parentheses here and 2 parentheses here. The first one is we're passing in a color, and the second is we're passing in this 3-number tuple. So this is what it should look like. After each one, we've got time.sleep, and let's go over to Python here, and I no longer need to be in the serial monitor, so I could just close the serial monitor here, and I haven't saved my file either, so what I'm going to do is I'm just going to make sure that I save it to my CPX. So I'll double click where it says untitled, and it should say CircuitPython in here. By the way, sometimes if you double click twice, you might see the cplay boot which shows up, you know, if you get those green lights which show up, but if you press it one more time you should be able to see CircuitPython there. So what I'm wondering is if I can get it to show up with the green lights. So yeah, there we go. I just got the cplay boot, but if I press one more time I should get CircuitPython to show up as well. Sometimes I've got, there we go, CircuitPython. So that's just in case you say, hey, I know I dragged over my CircuitPython stuff. What happened here? Just try to click again if it says cplay boot and you know you've got CircuitPython stuff on there, your UF2 file, and you haven't, you know, gotten in and done any make code stuff. So great. Now that I'm clicking on CircuitPython, remember the file that's going to execute is going to be code.py. It'll start executing right away. So I'm going to go ahead and save that guy onto my Circuit Playground Express, and then I'm going to run my code too, and it says I've already got a file there, but I'm going to write over the top of it, and now we can see I'm going through paint the rainbow. These are all the different colors that I had set up on the slide, so we can see these changing. I'm not sure how good they show up in the video, but you get a sense of what we've done, and then it's going to loop back after it's gone through all those colors and paint the rainbow. So hopefully this was an easy exercise for you guys, and you're learning a little bit more about how we can set things up and get our Circuit Playground Express to receive actions from CircuitPython. And just one more thing before we go to, why don't we save our file locally to disk? So remember, we saved this to our Circuit Playground Express, and if we save a new code.py over it, then we are going to lose what we already typed in here. Now again, you have it on the slides if you downloaded the slides too, but just to show you and make sure we know how to do backups. If you double click again on the tab here, what we see is our standard file save dialog box, and it looks more Windowsy. If you're on Windows, it looks like the Windows one. But if I click on my desktop here, because this is where I want to save things, and I'll just say with a new folder here, why don't I just call it CPX exercise files, or you can call it whatever you want. If I say create here, and while I'm in here, it says save as CircuitPy. No, I don't want to save it as that. I want to save it as, what did we call this? paint underscore the underscore rainbow.py. And again, this isn't something that I would drag onto my CPX because it's always got to say code.py if I want to execute it right away. But this is a backup version of my file that I can load up at any time. I can see that I've got it right there. So now that we've done that, hopefully this exercise was one that was pretty easy for you to conquer. And if not, hopefully it helped you understand some concepts as you went through this. And keep at it. We'll do some more in a bit.